Thanks, Riley. Much appreciated, and good morning, good afternoon, and good evening, wherever you may be. Welcome to Generative AI for Business Leaders. We're going to cover three things today. We have a fairly packed agenda. I'm going to talk about what is generative AI. I'll talk a little bit about the state of development, and I'll end up with what business leaders really need to know about generative AI and its impact. So let's just kind of quickly jump into this as to what it is. I'm sure you've all heard about it by now. Obviously, it's a subclass of artificial intelligence. What sets it apart from other AI systems is that it is very generalized. So, to date, most AI systems were very specialized. For example, you could build an AI system to recognize faces. It will be trained on a lot of faces, and it was very, very good at doing one particular thing. In my example, of course, recognizing faces. Gen AI is very different. It's been trained on a very large number of generalized cases. And so it's not a specialist, it's a generalist. Now, having said that, generative AI belongs to a class of AI models called foundation models, and foundation models were designed from the get-go to be customizable. So you can actually eventually end up with a highly specialized system that can, in fact, do facial recognition as just one example. So they can handle very generalized use cases. They're great because they can generate very novel and human-like input. People enjoy interacting with these systems because it's almost like talking to another individual. And you've no doubt heard about things like ChatGPT, where you have a chat interface where you can interact with. So these things are very approachable through these very approachable user interfaces. And these interfaces are being extended all the time. Today, text to text, text to video, text to images are very common, but we're now seeing other interfaces come to play as well, such as, for example, audio of different types and video. And as I said, these things have really been designed from the get-go to be enhanced and customized. And the way that we normally do that is using one of two different methods. We either tune these systems or we can prompt these systems to give us the kind of responses that we want. And I'm sure you've heard of prompt engineers by now. So Gen AI has many, many benefits. One of which is speed. It can handle much larger and more complicated tasks than humans possibly ever could. These things have been trained on massive amounts of data. They hold a massive amount of knowledge that would take humans several lifetimes to acquire. They're really great at content creation and content generation. They can often generate a lot of other resources. So, for example, it's become commonplace today to tune models, large language models, which are one type of generative AI, by using other large language models. And so you can generate, for example, training data for a smaller model using something like perhaps the output from ChatGPT or GPT-4. And of course, they are much more accessible than traditional applications, or many traditional applications using traditional programming techniques. Something to think about is that if the internet made the world flatter, then AI is certainly making the world faster. And we'll come back to faster and the rate of change a little bit later on in this presentation. Gen AI, as we know today, is really only about 2 years old. Of course, AI has existed for a long time in its various forms. But for a variety of reasons that I'll touch on a little bit later on, it's really needed the confluence of certain factors to come together to allow us to kind of exploit out this technology. So for 2-year-old technology, it has a large number of existing use cases. And this is just an example of some of them. Text generation, video and image generation, code generation, and of course, other types of generations, such as personal assistants of one type or another, different types of avatars, images that act and behave very much like human beings in many respects. And I see down the bottom right-hand corner, there's a thing called GPT. That is an example of a smart agent. And we'll see more and more of this kind of technology coming along. What this does basically is you can set it a task and it will go off and completely do it on its own based on your input. So, it's basically a hands-free kind of an operation. And if it needs additional information, it'll come back and ask you. So this area is moving very, very fast. There are many, many other use cases. These are some of the big dogs, some of the major players in the industry. I'm sure everyone's heard of OpenAI and NVIDIA. People like Amazon, not quite as in the media as perhaps OpenAI or Google, nevertheless have been doing a lot of work behind the scenes in the business-to-business environment, such as IBM, which, by the way, I don't have obviously on this particular slide. But these are the really big names. Keep an eye out for these folks because these folks are putting out a lot of content, a lot of data, a lot of models on a really high frequency basis. Okay, so that's just kind of a quick introduction to what it is. Let's talk a little bit about the state of development. First of all, patent activity in this area is absolutely exploding. Interesting point here is that 3 of these 5 countries are in Asia. So we're now seeing kind of a bifurcation of AI activity and patent activity between the United States and North America on the one hand, and Asia on the other. And you can see from this chart, China is very rapidly catching up to the United States in terms of patent activity. One thing that's driving all this activity is a concentration of AI scientists of one type or another. And this is just an example of that kind of concentration. If you look at these 5 companies, between them have about 33,000 personnel working in AI alone. As you can imagine, these staff interact, generate new ideas for new patents, and so we're seeing an explosion in patent activity. It's also one reason, by the way, why it's difficult to get AI engineers today. They've all been consumed by giants such as these. I want to spend a couple of minutes talking about some of the current technology, what sets it apart, and then I'll talk a little bit about where it's going. I'm sure that everyone has heard of ChatGPT by now. It is a general purpose model. It was released in late November, early December of 2022. Interestingly, by the end of December, it had over 1 million users, and 1 month later, it had 100 million users. So this technology has really taken off. Its general purpose, as this slide says, it's largely conversational. It's really 2 parts, a back end and a front end. The front end is a browser, and this has become the standard model. It's an endpoint for these sorts of conversational APIs. The back end, of course, is a large language model, usually hosted on the cloud somewhere. It could be AWS, it could be Azure, it could be, name your favorite flavor. One of the great things about these models is that they have what's called a context window. Think of this as a temporary memory where you can input information, it'll retain the context of the conversation or whatever you've input and provide an answer. Typically, today, these are 2,000 to 4,000 what we call tokens. Think of token as a word. It's not quite a one-to-one correspondence, but it's close enough. These things have also been trained in such a way as to provide some sort of a guardrail. That is, there are just some things that you can ask, but the system won't respond. Case in point, you may want to know how to break into a car. Well, the model won't tell you. You may want to know how to make methamphetamine. The model won't tell you. So there are guardrails in place, which is highly desirable. The successor to ChatGPT is GPT-4, and this is largely regarded as the gold standard, at least for now. This was released in March of 2023. It is absolutely massive. In fact, it's 6 different models, all of which coordinate together to provide the very high quality answers that the model provides. It's multimodal, which means that it'll actually take inputs from lots of different types of formats. It'll take image input, it'll take text input. I think before very much longer, you'll see it taking verbal input. It also supports a raft of third-party application plugins. Remember, I said that the front end of these models is usually a browser. And so it'll take a browser plugin. And what these things do is they extend the capability of the model without any need for tuning it or retraining it. And on the left, I've just got some examples of popular plugins. Zapier is essentially a zero-code way of exposing the model to the outside world. You could, for example, every time a large attachment comes into an email, Zapier will pick that up and then it'll forward that to perhaps GPT-4, and GPT-4 will summarize that for you automatically. So there's a lot that you could do with these, and these are just some examples. There are well over 500 plugins at last count, and they really do extend the capability of these models. An important point here is that these models, as they get bigger and smarter, also become more truthful, and they hallucinate less. And a hallucination is where a model basically does what a lot of humans do when they don't understand something, is they make up an answer. And so these models really behave like humans to a large degree. The more sophisticated the model, the more carefully that you train it by selecting the training data, the less it will hallucinate. And so these larger models are becoming much, much better at being truthful. Interestingly, as they pass a certain size, these models start to really exceed human performance in a very significant way, and I'll come back to that in a few minutes. But they also start to exhibit what I call emergent capabilities. Emergent capabilities are things that the model was never trained on. Remember that these models have all been trained on huge volumes of text, right? So they understand text in multiple languages very, very well. But when a model, for example, gets beyond a certain size, we've discovered that they start to teach themselves things like math, right? Things that they've never really designed to do. And we still don't quite understand how this works, but the more sophisticated, the more we start to see those sorts of emergent behaviors. And this really introduces some very exciting capabilities and possibilities. That was text to text. This is text to image. And this is a very well-known program called Stable Diffusion. You can see the very simple prompts underneath those images produce some really high-quality artwork. And as you can imagine, this is going to revolutionize content creation in lots and lots of different ways. The more sophisticated the prompts, such as the one on the right, you see the more photorealistic the image starts to become. And today, some of these images, it's really, really difficult to tell whether it's an image that was created or an image that was taken. And so welcome to the world of the deep fakes. We're also seeing a lot of activity in text to code. These are just some examples from two common products. One's called StarCoder, and the other one is Google's Bard. I'm not going to spend any time really dwelling on this. I only appreciate that these sorts of tools, and there are many more of these coming along, offer a huge potential for productivity improvements when it comes to coding. And it's always been difficult to get good, high-quality coders, keep them trained, and keep them in the firm for lots of different reasons. And these sorts of tools just help address some of those shortages that we're seeing around the world. One of the things that we're seeing happen with these sorts of systems is that we're developing ecosystems around the technology. And Google is a good example of this. Microsoft is another. Google released Palm some time ago. It's available to the open source world, and I'll talk about open source in a minute. But you really kind of need four things to develop an ecosystem around technology. The technology has to be flexible, it has to be customizable, it has to be scalable, and of course, it has to be accessible. And so we're seeing that Google is employing this technology across its entire technology stack. So right now, today, there are at least 25 Google applications that include some element of Palm, such as Gmail, Google Docs, and Google Sheets, of course, and search. And we'll talk about search a little bit more when I talk about Bing in a few minutes. But it's also highly customizable. And there are really two good examples here. One is MedPalm, which is a highly tuned version of Palm, strictly speaking for the tech med sector. And the other one is SecPalm. And SecPalm is actually used by Google Cloud as part of its security infrastructure. So these things are being deployed on a very wide scale. The other interesting thing about this kind of technology, and I mentioned scalability, is you can go from large to small, and that starts to open the possibility of blowing out the use of this technology across lots of different types of devices. And so Google has Unicorn, Bison, Otter, and Gecko. These are sort of 4 different size versions of its Palm architecture. Gecko is very small. It'll actually run on a mobile device. So you can see where this technology is going. 2 years from now, you'll have really sophisticated technology available on your smartphone. And of course, it has to be accessible, and there are lots of APIs for these systems being developed now that allow you to access them and then write your own applications using them. I mentioned open source earlier on. We're seeing a massive amount of activity in the open source world. It really started the way it did early on when we developed Linux as an open source alternative to proprietary operating systems. Open source AI models and large language models are developed as an alternative to the moats that the large companies have put around their proprietary infrastructures. You'll still see that from this chart that they're not quite there yet in terms of sophistication and comparison with things like GPT-4 or Claude, which is Anthropic's version. But I've got a bunch of these running on my engineering workstation. And I can tell you that the ones that I've been playing with recently are getting really, really close to certainly GPT-3 standard and even GPT 3.5. So it's just a matter of time before we're going to see the open source world and the closed proprietary world are neck and neck in terms of capabilities. And this is, of course, being fueled by the thousands of scientists all over the world that are working on enhancing and progressing these open source systems. So today, this is great. Today, we have the choice of commercially closed systems and non-proprietary open systems. And you'll see a lot more activity. I mentioned earlier on that some of these models have become very, very sophisticated. This chart just shows kind of schematically what's happened in terms of the relative sophistication level and capabilities of these models over time. And you can see that, for example, things like common sense, completion, math, code generation, language understanding have really accelerated rapidly over a period of 12 to 24 months. And today they're already at or beyond human performance levels. And I'll share a little bit of this later on. And interesting quote there on the right from Alan Thompson, who's an AI expert, where he mentions that things like GPT-4, tools like GPT-4, have already surpassed 90% of the human population in terms of capability, right? So think of these models being the top 10% of what humans can do and achieve. It is just the start. There are more and better models coming. This is, again, just a short, small schematic to illustrate the point. Products like Google's DeepMind, Gemini, and Anthropic's Claude Next are going to be coming out sometime this year. OpenAI is going to start training GPT-5 towards the end of this year, probably with a mid-2024 release. These are massive models, much larger than certainly GPT 3.5, otherwise known as ChatGPT, but also GPT-4. And they're going to bring with them a whole new raft of capabilities, much of which we have never seen before. They're certainly going to be larger and more accurate, hopefully more truthful. They will, as I said before, bring new emergent capabilities, but they're also going to bring some management challenges. And I'm going to talk about management challenges and what's going to happen once we start to achieve real, sort of general intelligence with these AI systems. What's made all this possible, of course, is the massive advances in technology, particularly in the last decade. And you can see on the chart on the left how just computing power has increased, particularly since 2010. Think of this as the cloud era, right? Once you have cloud and massive GPUs all arranged in series and parallel, you have massive computing capability, and some of these models take thousands of GPUs, many months to train and to produce. So it's a very expensive production exercise. We've also have massive data sets now that we can train these models on. One of the things about the internet, of course, is that it's flattened the world and it's generated massive amounts of data that can be readily mined. And some of these produce very high quality data sets that we can use to train these models. And with improvements in algorithms, we've seen a sudden explosion. So AI has been around for a long time. It's been on a steady increase, as pretty well as you can see on the chart on the left. But really, in the last 24 to 48 months, it has really exploded in terms of capability, driven by these technological improvements. Something to be aware of is that as these models become more and more sophisticated, so do the risks, the potential risks in using these. And this is straight from DeepMind, Google's DeepMind, which is, of course, one of the premier AI companies in the world today. They're very, very aware of it, and they've kind of put together this list of 9 different areas where there are some real potential dangers associated with the misuse of these technologies. These technologies are multi-use technologies, and so they can be used in lots of different ways, and some for good and perhaps some not quite so much. Just something to be aware of. And let me give an example of that before I move on to the next section, which is really about what leadership needs to understand about how to use this technology and where this is going. This is an example. It's a little dated now. It's a couple of years old. Well, not quite, almost. Megasin is a Gen AI model that's used for developing novel therapeutics, and it works from a publicly available molecular database. The way that this model was initially trained, really, it was given a series of rewards and punishments. One way to think about this is that every time the model gets something right, it gets a score, and every time it gets something wrong, it loses a score, and the model is tasked with maximizing its score. And so the model was trained really to win points every time that it developed something that was biologically very active, but non-toxic, right? So you can see the obvious application to new drug discovery. However, it's a dual use. And the model was also trained in the exact opposite. So it was rewarded every time it developed something that was biologically active, but also when it was biologically toxic. Right? And this is one of the potential dangers of this kind of technology. As the slide says, that model generated 40,000 lethal compounds in under 6 hours, including many, many known chemical warfare agents. The point here is that it is a fantastic technology. It brings fantastic capability. But with that capability comes fantastic responsibility. And that is going to require some regulation to mandate how they can or cannot be used. Now, imagine this kind of technology in an open source world where the regulation isn't quite as tight as it is for some of the proprietary technology. And on that cheery note, let me talk about what business leaders need to know. This is a study by McKinsey. And the take-home message is that generative AI is going to increase productivity dramatically. McKinsey looked at 63 Gen AI use cases across 16 functional areas and 850 occupations. They estimated that the implementation of AI would add about $11 to $17 trillion to the global economy every year, right? So that's kind of approaching the US GDP. Of this, Gen AI alone was going to contribute between 25 and 35%, mostly from cost reductions and increasing worker productivity. They also worked out that 75% of the Gen AI value was expected to come from increasing productivity in 4 areas: marketing and sales, engineering, R&D, and customer service operations. So bear that in mind when we talk about how to apply this stuff a little bit later on. So this is a really dramatic improvement in productivity. And because of that potential, this technology is really taking off. And it will vary by industry and job role. We think that the areas that are going to find the best use and the highest productivity gains are going to be in the fintech sector, in high technology, and of course in the life sciences. And I gave some examples of that a short while ago. McKinsey believes that around 60 to 70% of an employee's time can be saved by automating repetitive tasks, and that is pretty dramatic. It also means, of course, that we have a potential here to really accelerate the pace of workforce transformation. If you look at the chart, the block diagram on the right, the areas in the darker blue, the areas that offer the highest impact for productivity improvement. You can see that marketing and sales, R&D, and the other two areas that I talked about feature pretty prominently. And so these are the areas that we're seeing, by the way, a very rapid rollout of the technology today. There will be consequences. It does raise the issue of what's the future of work. Right now, Goldman Sachs estimates that up to 300 million jobs may be disrupted by the broad implementation of this kind of technology. They estimate while AI will replace sometimes, it will more likely enhance. And they estimate that 25% of the current tasks across the whole economy can be automated. And the natural consequence of that is that about 7% of the US workforce will likely be displaced over the next 5 to 10 years. That means we need to find productive employment for at least 12 million Americans. So that's just something to think about. Of course, what's also going to happen is that the remaining 63% that will have their functionality complemented by AI will become much, much more productive. And so they estimate that about 50% of today's tasks will be automated as early as 2045. And frankly, I think that is being overly pessimistic. I think it's going to happen a lot sooner than that. It also means that unlike previous transformations to the economy, the group that will be the least affected this time will be what we call mostly blue-collar positions. So these will be largely unaffected. It's really going to affect the knowledge workers, the clerical workers, and what I call the folks in the middle who will face the largest displacement, but also the largest complementation with this kind of capability. Of course, with this, there will be no shortage of policy challenges, and this is just an example of some of them. We will definitely see a reshaping of society. There will be some very large and unplanned workforce transition that we're going to have to deal with. I've already mentioned, what does this mean for the future of work? How can we support workers as their activities shift over time? How do we really teach workers to spend a lifetime learning and relearning? Because that's the world that we've already moved into, and that will be accelerated by the implementation of AI in all of its forms. It also needs to address the issue of what policy steps do we need to take to prevent the worst elements of generative AI harming society and harming our vulnerable populations. And also, of course, the issue of privacy and security. So there are a whole bunch of policy challenges. And as I think things stand today, I don't feel that our regulators are knowledgeable enough to be able to make sort of intelligent progress in this area. They definitely need some help. It's great to see that our regulators are really trying to learn. Stanford ran some policy sessions for members of Congress, I think it was last week or the week before, as an attempt to address this. My point here really is that it's not just regulators, but pretty well everybody is largely unprepared for this impact. And so we need to scramble pretty fast to address these challenges, but also address the regulation issue, because we really need to do that to prevent the worst aspects of some of the potential here. In this case, by the way, while Europe may not be leading the way in patents, it is certainly leading the way when it comes to regulation. The European Parliament recently voted on what they call the AI Act, and this is a draft law which has now gone to the individual country members for ratification. but ratification is expected by the end of the year. And I think therein lies a really good model for the sorts of regulations that Congress should at least consider employing and deploying here in the United States. Interestingly, most of the popular models today don't meet the current EU standards. And so everyone is currently scrambling to work out how they will. This is going to be as disruptive to the AI industry as GDPR was to the marketing industry. So again, here Europe leads the way. Everyone has a little bit of work to do, but I'm sure that we'll address this as we've addressed most things in the past. As I move towards a close, I just want to sort of provide a little bit of advice for the CEOs and other leadership listening to this presentation. These are some of the areas that are primed for automation, and I've already addressed some of this in the previous studies by both Goldman and by McKinsey, of course. But really, you should start looking seriously at how you can start to deploy this technology in your own organizations. And here are just some guidelines for where to start. Those bubbles across the top are areas that I think are really prime for pretty well immediate review and automation. To really start here, you need a very clear understanding of what are the problem areas that you're trying to address, or the opportunities that you're trying to address. So, for example, if you're having issue sourcing adequate technical expertise and writers to develop high quality content, then that's an area that's ripe for automation. And then there are a number of tools that would probably fit the bill. So there's some research work involved here, but you need to clearly understand what the problems are that you're trying to solve, or what the opportunities are that you're trying to take advantage of. And investment in data is really essential. Remember that I said that these models can be tuned. They've been designed to be tuned. You typically tune them by using your own proprietary information. So the quality of your data and the quantity of your data starts to become essential in being able to tune these systems to do what you want them to do. Be cognizant of security, and I'll talk about this just on the next slide, but use a multi-layered approach. These models do introduce an entire new range of security challenges as well. I already mentioned that recruiting staff and keeping them trained, because this technology is moving very rapidly, and retaining them is critical. This is a critical success factor for successful implementations. So be slow to hire, quick to fire, but be very careful as to who you bring on board, because this truly is a critical element in the success, particularly of your early, first forays into automation with Gen AI. Of course, establish guidelines for its use. Be very careful about things like access to proprietary information and personally identifiable information. You can get into a lot of trouble that way. If I can jump onto ChatGPT and find out all about, your customer base, for example. And monitor the outcomes. Obviously, things like accuracy, efficiency, and cost savings. Obviously, once you start to monitor this, you'll start to get a really good sense of how effective and how efficient these systems really are, and what it means in terms of both productivity improvements and cost savings. And as the slide says, start slow and then accelerate. Get a few wins under your belt before you start becoming too ambitious in this area. It's very easy to get enthusiastic and kind of rush ahead. But as the old saying goes, slow and steady wins the race. Not too slow, because obviously all of your competitors are going to be doing this as well. But make sure that you get a few wins under your belt and then start to accelerate. Put the as we say, put the pedal to the metal as you start to look at other areas that can be automated. Just some gotchas or potential gotchas. These are some limitations that you should be aware of. These systems are not perfect. These systems make mistakes. They have issues with algorithmic bias. Remember, these things have been trained on huge volumes of data. The data itself is not unbiased. There are issues of intellectual property and infringement. We're already starting to see some legal cases brought against people like OpenAI about the training sets that they used, because they use things like books, for example. Be very careful of privacy and make sure that you lock down anything that involves personally identifiable information. Really important. Security, as I said earlier on, brings in a whole raft of new challenges. It's actually quite easy to poison, it's called poisoning, a generative AI system or a large language model. You can tune them by changing a fraction of percentage of the data, and you can tune them to do all sorts of things that you may not want them to do. And bad actors, by the way, are doing this already. There's a bunch of this stuff already available on the dark web. And so really, cybersecurity has become a matter of, sort of strike and counter strike, if you like. Just be aware of that. You will require to implement a lot more layered security as you start to use these systems. Interesting, these systems and how they work is very difficult to explain. And even today, we don't really know how they work. Some of these models have huge numbers of parameters. Think of a parameter like a neural connection almost, measured in the billions, right? They give us the right answer, but we still don't know how all of these things interconnect and work together. So we know how to manipulate them, we just don't know, and still don't really know how they work and why they work. There are issues with reliability. It's quite possible to get a different answer with the same prompt. You know, if you want to convince yourselves of this, go to something like Stable Diffusion, change the seed number, and you'll get a totally different image for that identical prompt. And the same thing works with the language models themselves. Also be aware that as you start to implement these systems, there will be an organizational impact, and you really need to plan for this as a member of the leadership team, because some of these transitions may not be particularly pleasant. As I drive towards the close, these are some things that I think you as leaders really need to get across. And these are 3 readings that I would highly recommend. I refer to all of them, or elements of all of them, in today's presentation. One is The Economic Potential of Generative AI by McKinsey. The other one, of course, is What Every CEO Should Know. And the final one is Goldman Sachs' article on the potential large effects of AI on economic growth. And these are very credible sources. It's lengthy reading, but it's fairly light reading. And if you want to get into the weeds of the potential and some of the potential gotchas, I would highly recommend these. I just thought, as a matter of interest, I put this presentation together about a week ago. And I just thought I'd illustrate how rapidly things are moving by looking at what happened in that 1 week between when I wrote the presentation and when I'm giving this presentation. The first one is that Gen AI has actually worked out how to solve captchas. You remember those captchas are those really annoying little graphics that you see that when you try to log onto a website, they get you to solve a little puzzle. Well, guess what? AI has worked out to solve those things now, so they're no longer very effective at all. Microsoft Research has validated GPT-4 is more than good enough to automate a very wide range of medical tasks, such as clinical trial design. And so you can see where this is heading. Related to that, there's a new product called Dr. GPT. It's an open source large language model. It's been trained on medical data sets. And by the way, this large language model has passed the US medical licensing exam. The cool thing about this is that it fits on most devices. So in the not too distant future, you'll be able to have your own personal physician, or at least your personal diagnostician, on your cell phone. Stability AI has released Stable Coder. This is a very high quality large language model specifically designed for helping programmers program. And they've also released Stability Chat. And this is a Chat GPT competitor. So everyone is trying to come out with something that will compete with GPT-4 and Chat GPT. The Department of Defense has established a Gen AI task force. And Microsoft has authorized the use of Chat GPT on Azure. This, by the way, is very significant. One of the biggest challenges with deploying generative AI and these models has been the whole issue of what do you do with proprietary data. You don't want to load proprietary data onto these models and just have them parsed by Microsoft or OpenAI or who have you. And the fact that you can now put this on a container, essentially, on Azure or another cloud architecture means you can now keep all of the data proprietary and still access the back end to a large language model. So this is really a significant boost to productivity and adoption, particularly for large and medium enterprises. And finally, Google and Universal Music are working on a licensing arrangement for AI-generated songs, which are really becoming quite spectacular. And all of this in just 1 week. So the rate of change is increasing. If I were to do this in another week, I'm sure I'd have a totally different list. Okay, just some closing thoughts. Gen AI is a true disruptor. I think it's out there in terms of social and economic impact with the invention of electricity, the invention of the transistor, the internet, and so on. The change has been slow to get here, but it's going to accelerate really rapidly. And so we need to try and stay on top of these things because they are definitely going to have an impact. The new systems have already surpassed humans in many, many tasks, particularly tools like GPT-4. Claude is up there as well, and some of the other models that I've mentioned. We are probably about 18 to 24 months away from what's called artificial general intelligence. That is an AI that surpasses humans pretty well in every possible area. It is a truly generalized model. We're probably 5 years away from what's called superintelligence, and that's going to bring an entire new raft of opportunities and challenges with it. Embodiment is something that I haven't really talked about, but we're now starting to see These AI systems getting incorporated into things such as robots, largely driven by cheap and inexpensive DC motor technology, also things like advances in 5G, battery life, and so on. Think of a robotic dog that has a large language model embedded. It can look at things, essentially smell things, process this, and then actually talk to you. That is just around the corner. I talked about the importance of open source. With great power comes great responsibility. Open source is going to definitely accelerate and is accelerating the rate at which these models are being developed. Interestingly, we're seeing a lot more M&A activity in this area. Remember that a lot of large enterprises innovate through acquisition. And as we saw more and more open source technology solving harder and harder problems, I expect to see more and more M&A activity as those firms get bought up for their innovations. And finally, we're already seeing a huge amount of investment in this area. And this is only going to increase over time. And again, as a result of that, we're going to see more and more M&A. So thank you very much for your time. I know this has been a long presentation. I hope you found it useful. And I'm just going to leave you with a couple of thoughts before we sign off. As the CEO of Anthropic said, the single most important thing to understand about AI is how fast it's moving. And with that, thank you very much.